Okay, what we're about to do now is kind of what integration is all about. We're going to do what I would call your basic geometric understanding of how to find bounds or sums above and below or upper and lower from a curved structure. It's really difficult to find an area of a curved structure since it's constantly changing its slope. So what we tend to do in the old days, we would find an area of columns or rectangles that we've drawn underneath and above the curve, and then kind of take an average of the two, and we'd be fairly close, not wonderfully close, but fairly close. So this is what I've done here. The graph here is y equals 5 minus x squared. This is example 3 in the book. You want to take a look at that. But this is pretty much how they've done when I use pretty colors for it. They just use black and white. So that shows you how wonderful a person I am. Anyway, so what we're going to do is we're going to find the areas of these columns above, starting at a point at which it's going to intersect the curve. That's important in this. So the red one starts right here at 5 or 0.5 rather. And so we've taken this curve and divided it into five chunks, equally spaced, and that's important. They must be equally spaced. And so this is 2/5, 4/5, and so because we took 10/5 and divided it into 5, which is 2/5. So everything's 2/5 apart. And so to find the area, we take 2/5 times the height of each of these columns for the green and for the red. And since these are all 2/5, they're all multiplied by 2/5. Okay? And so what we did here was we took, we calculated the values here. The equation is 5 minus x squared. And so this is 4.84 here, 4.36, and all the way down to 1 here. And then we multiplied all these values times 0.4, which is what the fraction for 2/5 is. And then added them together. Now, this is what we got as a result. For the above columns, or as what we call the upper columns, the upper columns came out to be 8.08. And the lower columns, we multiplied each of these by 2/5, we got 6.48. So we know that the range is somewhere in the middle of 6.48 and 8.08. I don't know how you see it, so I'll do it right here. Now, if I were to divide that out into 25 columns instead of just 5 columns, I'm going to get a much more narrow range than what we had with this right here. And so when we do that, we find the values here of 7.17 and 7.49. So it's a difference of only about 0.32. And we take those two and add them by 2, or divide by 2 rather, we get 14.66 divided by 2 is 7.33. And it turns out, when you actually do the calculation, which is the next topic that you're going to be dealing with, and oh, what a delight that is. Not really. We get the actual value to be 7.33. So you get to a certain point, and you're going to get pretty close to the value. Just the question is, do you want to sit there and draw 25 rectangles out of that? And the answer is no. So we want to come up with something. Well, it turns out if we keep dividing it into smaller and smaller columns to the point where we get infinity columns, this is what you get. So obviously there's going to be some integration involved and summations involved. Everything that we've talked about up to this point here is going to be a big deal. Now, there's not so much integrations, that's going to come later on, but what we are going to be dealing with right now are summations. And So the chart that we have on page 260 is going to become important, but not in this section, but it will for the next section. This section, I just want to do a practice problem. There are some graphs in your problems that you're going to be doing, and I want you to do the upper lower. If there's no pencil marks in the book, please don't put any in there, because we're going to have students using this for at least 4 more years. As long as I'm here, we're going to be using these books. So don't mark in there, but you can kind of use a ruler and guesstimate your value from that. In the case of problem number 23, we have here an equation that is really not important. You can just estimate the lines here, but in fact, the book does not even give you a value of the function here. It just gives you a curve and says, hey, make some lines above or below the point of contact between the curve and a distinguishable point on this right here. So this is probably the trickiest one right here. But if you look at the distinct points that you can see from there, and actually if I look at this right here, this is, well, we went every one, so I guess we really don't need to do that. We went every one here. So the continuous separation is 1. We could do this right here, but it's going to mess up, even though my drawing is not the best in the world. Shocking. But they are supposed to be 1 apart, even. So, and as you can see right here, if I look at the lower one for this one, 1 goes across and 1 up. And so this is going to have a value of 1. So this is 1 times 1 plus, and then the below for this right here is going to be 2 times 1 plus this one right here is going to be 3 times 1. This is pretty tricky stuff. Plus, now I have to do a little estimation. This looks like about halfway between the two. So this is going to be a height for this last one here being about 4.5 times 1. So we'll do the calculation. 1 plus 2 plus 3 is 6, plus 4.5 is 10.5. So that'll be my guesstimation based upon that. Now, if we do the above ones like I have up here, then that becomes quite a bit different. This goes all the way up to 3 before it hits 1. So this is 3 times 1. And then this one is going to be 4 times 1. This is going to be 4.5 times 1. And then this is going to be 5 times 1. Actually, this 5 times 1 for this right here. So we get what? I don't know, with 11, that's 16.5. So the upper range is 16.5, the lower range is 10.5. So we can guesstimate that the curve is going to be somewhere around 13.5. Now, this is only 4 columns, so this is a very good estimation. But that's how we're going to do these problems. So, your practice problems for this. Page 268, 24 through 30. And what I would like for you to do in those problems is tell me what you got for your values for your length and width, and therefore all the rectangles you got, and then from that give me a sum and an estimated area underneath the curve. Okay? Have fun.